Hello and welcome to this webinar on concrete design and improvements, new features in FEM Design 22. My name is Isaac and I work as a developer, sorry, not a developer, I work with business development here at StruSoft. And with me today, I have Frederick, which will be available to answer any of your questions. So I would encourage you to provide your questions in the GoToWebinar all the way during the webinar, and he will get to them during the webinar. And if there is any remaining questions, we will get to them at the end of the webinar, and if I need to demonstrate something extra. So this webinar will be recorded, so you can view it later on if you miss a part of the webinar or anything like that. You will get an email after the webinar with more information about the recording. So very welcome to this webinar. Let's start. So the agenda for today is basically to show you the new features for concrete design, for bars and shells, and also some tips and tricks and common misunderstandings that we've come across during our work in the support. We will start with the bar design. In this list, there is both improvements in the last version 22, new features and improvements, but also older features that maybe not that well known. So hopefully it will be a good introduction to the complete concrete design of FEM Design. So we will start with a new feature called shear and moment reduction over support. We will continue to show some different settings and ways of defining reinforcement in bar elements, as well as the interaction surface and more detailed results that are available in FEM Design. Also show how you can group different objects to obtain automatic sections that are the same for every object within the group, as well as some improvements and how we can utilize the concealed bar feature, which is really nice in certain situations, which I will demonstrate. And we will then continue with the fire design for bars. That's the first part, that is the bar design. And then after that, we'll continue with shell design also. But let's start here, and I will go over to the software and show the model that we are working with today. So this is a concrete model, and it has a foundation of end-bearing piles, and it's a combination of precast but also in situ cast concrete. And one of the facades is a glass facade, which is modeled with a cover to distribute the loads. So there is no load-bearing facade in this part of the structure. So let's first start with the moment and shear reduction zones that are new in the new FEM Design 22 version. So let's switch over to the analysis tab and take a look first at the moment. So this is the moment for the internal force for the bar. And if we take a look at the moment here, you can see, let me just rescale the view here, 0.1 is good. We can see the moment distribution without any reduction for this bar. And that's always the case when you're viewing the analysis results for the different objects when it comes to the bar internal forces. So the bar internal forces, it's without any of these reduction zones adjustments, that is according to the Eurocode. However, they are applied when you go into the RC design tab. So let's switch over to this. And in the design selector, I will select the bar reinforcement. And here we have a new button called reduction zone. And here it's automatically defined, but you can change the settings if you wish. So here I can define my own reduction zone with the pen, or change the properties of existing reduction zones with the question mark. And the reduction zones are visualized in the 3D view by these thicker black lines, as you see at the ends of this bar object. So let's take a look at this end, and we can see the settings for this reduction zone. So first thing is the size of the reduction zone. You can calculate it automatically based on the support size, or you can select your own size of the reduction zone. You can also choose between two different options. And the first one, it's according to 5322 paragraph 3 in Eurocode. Let's just view that real quick here. So if we take a look at the Eurocode, you can see under section 5322, there are some instructions on how you can reduce moment and shear force for beams. And this paragraph 3 is related to mostly fixed supports, I would say, while paragraph 4 is related to hinged supports. You can read the details here as you wish in the Eurocode and check it out in detail. But you have the option to either select this according to paragraph 3 or a reduction according to paragraph 4. But since this is a fixed connection at the end, I will use the recommended for rigid connection. That's the first setting. You also have the option to either apply a reduction for the shear force or not. So it's the same for the moment. So now when I've applied this, we can take a look at the RC bar design forces. They appear when I've checked the bar. So I will continue to apply reinforcement in this bar, and we will check back on the design forces and compare them to the analysis forces. So let's continue with how you can actually apply reinforcement in this bar object. And I just want to highlight some of the features that's been implemented during the past 2-3 years that's really made the bar design in FEM Design a lot better compared to previous years. And it's related to both manual design and auto design. So we will start out with the auto design. Well, first of all, you can always find the settings for the check under the cogwheel and under the calculation parameters. So the first settings found under the configure RC design, the cogwheel here, they will affect all different design situations, regardless if it's a shell or a bar or a punching region or whatever it may be. And in this case, it's relating to how to handle the second order effects and also which load combination should be used for the crack width calculation. And also there's an option to calculate reopening of cracks. So otherwise the crack limit will be FCTM, which is the tensile strength of the concrete. And if the force exceeds this limit, the section will be assumed to be cracked. But it can be a case that a structure has been subjected to a larger load in the past, and you want to, it's already cracked, and you want to calculate the crack width of reopening of these cracks. Then you can assume, check this checkbox and assume the whole section, all of the model to be cracked once. So this will mean that you will get crack width in every part of the structure except for parts which is under pure compression, basically. But we don't want to change that in this case. We will go with these settings. And then you have the object specific settings found under calculation parameters. You can right click on an object and find these settings. So I won't go into too much detail here, but you have some settings for the Eurocode check, basically. And also for the eccentricity applied for the section. You also have a tab related to the fire design, and we will check more in detail about this later on in the webinar. So let's go into the first show how to apply reinforcement using the auto design. And we will use the lightning symbol here, auto design, and click on the question mark icon and select one or multiple beams. In this case, we will just select this beam. So the first window, you can select which type of sections should be available for the software to choose from. And I can select whichever I want, and it will apply the reinforcement content up to a certain limit, which I set on the next tab. And if it's not enough, it will go up a section from from this. So let's go to the second tab related to the reinforcement content. So the first setting that is quite new, it's like 2-3 years old, it's related to the reinforcement symmetry. So this is really useful when dealing with beams and columns, since you often want to have symmetric reinforcement in some way. So you can either choose to have the reinforcement placed symmetrically around the principal axis number 1, or the principal axis number 2. So the 1 axis is in the local x direction, and the 2 is the local y direction in this case. You can set the diameter for the stirrups, the longitudinal, primary, and auxiliary reinforcement. You can also set the cover distance for a specific edge or all edges. So the specific edge selected is shown by red in the view here. And if you change it to 25, for example, and click set, you will see that this has changed only this edge for the concrete bar. But let's set 20 and set all. Here at the bottom, you have the allowed reinforcement ratio, which is basically the ratio between the reinforcement content and the cross-section of the concrete. And this will define if it needs to step up to a larger section, or if it's enough to just put as much reinforcement as needed in that specific setting. So if you want to optimize and find an economical or even environmentally better solution, a good way could be to adjust this in a little bit more detail to find the relation between the concrete and the reinforcement in the section that you find is suitable for your projects. But let's go with these settings. Then you have the last tab related to manufacturing, and it's basically the size of the aggregate used in the concrete. So we will click OK and apply an auto design to this bar by clicking on the exclamation mark and right-clicking on the bar. And now the reinforcement content will be generated in the bar. In this case, we have quite many load combinations because it's wind in many directions and also snow load. So it can take a little while to apply the reinforcement depending on how many load combinations you have. Also, when I'm sharing the screen, it also takes a little bit longer time than normal. Okay, so now I have a result. So first off, I want to show that you can now visualize the reinforcement content in the 3D view by going into the Quick Tools menu, clicking on Display Settings, and under Detailed Settings and Reinforcement, you can check the bar reinforcement and view the reinforcement content in the 3D view. This is very useful in my opinion, because you often want to just check if it seems reasonable what the program generated. Let's take a look and rewind a little bit to the design forces. So a little bit further down in the list of the results, you will find the RC bar, and here you find the design forces. And these forces here found in this section are with regard to the reduction zones that we just applied. So these will vary a little bit compared to the bar internal forces found under the analysis results here for the load combinations. So in this case, it is with regard to these reduction zones, internal forces with regard to reduction zones. As usual, when working with FEM Design, you can always obtain detailed formulas, step-by-step formulas, if you go into the utilization results and click on the magnifying glass and right-click on an object. And this will give you a step-by-step documentation for all the different checks performed for this section and this object. So you can see the stirrup utilization, concrete utilization for shear and torsion, and so on, and also the crack width calculation here. So that is how you can apply automatic reinforcement in a bar object. I will also briefly show how to apply parametric reinforcement manually. Let's zoom out a little bit and do this on this column instead here. So instead of using the auto design, you can use the manual design, and here you can find the parametric reinforcement. This is also an old feature. It's maybe 2 years old, but it's not that well known yet because it's still pretty new, but it's not a new feature in FEM Design 22. So here you can apply reinforcement according to parametric settings. So if you go into the default settings of this tool, you can find the under the general tab, you'll find some concrete cover settings and also some settings for the stirrups. And this is automatically divided into 3 different sections. So you have a start section with a distance and a spacing and a diameter. And then you have a mid section with a spacing and diameter and an end section with the same settings. Then you have the longitudinal bars. You can either orient them as like a beam reinforcement that will be symmetrical around axis number 2 in this case, or you can apply them as a column reinforcement, which will be fully symmetrical. And here you can basically set the different settings for the applied reinforcement and then just basically right click on different objects to apply that type of reinforcement. And this goes pretty quickly if you have a larger model and you maybe have set up the manual reinforcement by parametrically, and you can just right click to apply this on multiple stories and multiple objects very quickly. So let's go back to this calculated beam on story number 4 that we auto-designed. So I will just also want to know that when you have applied reinforcement, you can of course make changes to the applied auto reinforcement. And you can access these settings by going into manual design and selecting draw. And here you can just right click on the object and it will go into a new view where you see a cross section over the reinforcement in that section. This section is shown at the marker here. So if I change the position of this marker and place it in the middle, I will see a section of the middle. In this case, it's the same reinforcement all the way through the beam, so it's the same layout. But here you can also see the interaction surface, and this is very, very useful when dealing with concrete design, since compressing normal force is beneficial to the moment capacity. It can sometimes be a little bit tricky to ensure that this compression force should be there all the time together with the moment. So a very clear example is a basement wall. So maybe the most critical loading situation for that basement wall is before you actually load the complete house, maybe even during erection, just when you have filled up with earth pressure for the wall, but you have very low normal force in the wall. Since the normal force, the compression in the wall is a contribution to the moment capacity. The moment capacity may be the lowest when the house is unloaded with no normal force in the basement wall. So that's just an example. So that can be identified quite easily by studying this interaction surface. So basically, this is an interaction surface with the normal force on the z-axis, moment in the x and y-axis. And if we take a look, if we go higher up on the normal force compression, you will actually be able to carry a higher moment. So if we had a point, these 2 green points indicates where we are actually at in the cross section for this. So in this case, it's with a normal force of 0. So we are not at risk of doing this kind of error. But if we should be maybe up here, you actually rely on the compression force in the section to be able to carry that kind of moment. So in that case, you have to ensure that that compression is always there together with the moment. Otherwise, you will go down to the 0 level of the moment and you will cut the surface of this interaction surface and thus a overutilization of the cross-section. So you can also take different cuts in this interaction volume. So let's say that we want to take a cut on the 0 level, and you can see an interaction between the moment in y and x direction. So it's a useful tool to find these kind of issues, because you often think that a lot of load in the model is on the conservative side, but in this case, it's not necessarily conservative to add a lot of load in the model, since it could generate a big normal force in the object, which then in turn is beneficial for the moment capacity of that object. So I hope you're following along on my train of thought there. All right. So let's switch back to the just make a quick summary. We've talked about the shear moment and reduction over supports, auto design, parametric design, and interaction surface. Let's continue to talk about the grouping and concealed bar improvements. So when you do auto design, you can also group different objects. I will show this very briefly, but there is an option to define different design groups. And here you can select multiple objects and place them within a group. And the software will apply the same reinforcement in each group, and it will take the worst situation for that group. So it's a very, so in this situation, for example, it's very beneficial to have a group for all these objects, which is the same length and placed in the same part of the structure. And you will generate the same reinforcement for all these. So you will save time and also have the same detailing for multiple objects in the model, which is usually very beneficial. So I would recommend to check out and try out this design group feature. Let's continue to the concealed bar. So if I change my design selector here and instead select my concealed bar reinforcement, I can actually translate part of a shell to design that as a bar. So let's say that I want to design this part beside this window of the shell as a bar with stirrups and longitudinal reinforcement. I can do that through the concealed bar feature. So the first thing that I want to do is to specify the concealed bar. And in this case, I just right click on the object to select the shell and draw, now I'm actually on the user defined direction. So let's first show the local system of the shell. So I right click on the shell and I can draw a rectangle to define the area where I want to define this concealed bar. So in this case, it's according to the local system of the shell. And if you're actually trying to design in another direction, you can use the change direction to swap this. But in this case, I want it as a column, so I'm happy with that. But you can also use it in a skew direction, a user-defined direction. If you have a more complex geometry, you can actually place a concealed bar diagonally in the skew direction, so it doesn't have to be like X and Y or something like that. So, but let's remove this and continue with this. So otherwise, besides the definition, it works exactly the same as the bar design. So I can use the same parametric reinforcement, manual reinforcement, and auto design to apply reinforcement in the concealed bar. So let's just apply some auto reinforcement here and take a look at the results. Because what is happening in the background is that the software will integrate over the area of the shell to obtain the forces in a line. And this line will then be designed as a bar object. So if we take a look at the results related to the concealed bar, let's see here, it should be at the bottom, RC concealed bar, we can view the internal forces obtained from the shell. So let's take a look at the normal force, for example, and here you can see the normal force integrated from the shell results into a line, and then we've designed this line. So this is very useful when you want to design like this part on the side of an opening, or maybe it's over a large window or door or something like that. You can use the concealed bar. All right, so that concludes the bar design. I will talk about the fire design a little bit at the end of this. And I will instead continue to the shell design. So first I want to briefly show the shell of longitudinal bar, the RC shell design for longitudinal bars. Then I want to show a new feature called single bar, and also something new called shell crack width design. Also shear reinforcement design, which is also a new feature. and also RC shell fire design, which also is a new feature. So it's mostly new features when it comes to the shell in my demonstration, which comes now. So let's swap over to the shell design found here in the design selector. So it's surface reinforcement longitudinal. Let's start there. So in this case, I have a pop-up window which will show me different layers, and I can select like the bottom X, bottom Y, and also bottom single, the same for top X, top Y, and top single. And you have also the possibility to have a single layer of reinforcement in the middle if you wish. But in this case, I'm going to use two-layered slab, which with reinforcement both in the bottom and in the top. So let's start out with an auto design. As usual, you will find the calculation parameters, the settings for the different objects under this button. And I can select the question mark and right click on the slab. And here I can set the default reinforcement used in the slab. And since all results are presented in square millimeters per meter, which is an amount of reinforcement, it has to be related to a quality. So that quality is set here in this window. So the recommendation is to choose the quality that should be used in the project. And when it comes to the diameter and the cover, for the diameter, it is used to calculate the minimum and maximum reinforcement limitations, but also the required reinforcement result, which is also square millimeter per meter, and that needs like a diameter and also mainly a cover, actually like a lever arm inside the section. So the recommendation is to set these settings equal to the base net applied that should be applied in the model. I can also set the allowed crack width and also some settings for the eccentricity and if I want to apply minimum reinforcement or not. So let's continue with the auto design. The same way here, I find the settings under the question mark and I can define a base net and additional nets by fixed diameter, which is, in my opinion, the most commonly used way of doing it. So this will mean that the software will apply a base net of 10 millimeter bars with a spacing of 300, and it will place additional reinforcement according to the steps allowed in this window. It's the same settings for the top face here. Here at the bottom, you will also find the crack width. So this is a new feature in FEM Design 22. You can actually design the reinforcement content with regard to the crack limitation set under the calculation parameters. So let's uncheck this for now and take a look at the result, and then we can run another design with this checked. So let's run the design and take a look at the results. All right, so we have some generated reinforcement. It's the same way for the bar reinforcement as for the shells, that you are now able to visualize the reinforcement content in the 3D view, and it's the same found in the same place. You can go into this display settings and turn on the shells in bottom X and top X, Y. And here you can see like a graphical representation of the applied reinforcement, which can be very useful in some situations. But for now, let's turn off these and take a look at the different areas defined by the software. So you will have the base net. In this case, it's in this blue color, and you will have additional nets applied in this red color. So it's easy for you to find the additional nets applied by the software. And this is for in the bottom Y direction. It's the same for the bottom X and in the top, and so on. So let's take a look at the utilization first. We will look at our RC bar, sorry, not RC bar, RC shell and utilization. So let's take a look at this opening here. You will see that the software wants to apply an additional base net at this corner. And You can keep it like this, but in this demo, I want to show the single bar setting. So how you can actually exchange this additional field of reinforcement by single bars instead, which may give you a better and more economical design. So let's remove these actually, and both in the top X and top Y direction. And you will see now some overutilization at this edge. And as you can see, the result is automatically updated when I make changes, and you have a setting here that's auto update RC shell results if they already exist. I can turn on and off this here, but I want to keep it. It's easier, in my opinion, to work with the software when doing manual design, when you get an instant feedback and an instant result from the software. So let's go into the manual design. And here there's a new option in FEM Design 22 where you can select single bar. And you have a new layer also called single top and bottom. So I will place myself in the top single because it was overutilized in the top. And I will apply some single bars. So you have the option to draw them by endpoints or by shell edge or shell corner. Let's start with shell corner and see how it works. So I can just select this corner and it will apply reinforcements in the corner like this. I can of course change the properties. I can change the cover distance, the diameter, the spacing, and the number of bars. I can also stretch this area to fit my needs. But for now, I can see that there's still some overutilization, so maybe I will try the by edge instead of the corner. So I will remove this and apply the single reinforcement along the edge instead. So let's go back and select by shell edge. And here I can just right click on the edge and it will apply single bar reinforcements along that edge. And it's the same for this edge. Okay, so I will get a warning here because these are crossing. They have the same cover and therefore they are crossing. So let's change that a little bit. So let's change these to have a cover of 50 instead, so they won't collide. And I will also maybe add an extra bar in this field because it's still overutilized a little bit. So let's change it to 4 bars and maybe a little bit larger spacing of 120. And now you can see that there is no longer an overutilization. So, but there is still maybe unnecessary reinforcement at the ends here. So it's up to you to, of course, to design this the way that you want, but I will just draw some help lines here that I will stretch my reinforcement to. So let's grab this end and stretch it to here, and also grab this end and stretch that here. So now I have changed these additional fields in the top in X and Y, instead applied single reinforcement along the edges in this specific area where I had a overutilization. So I hope this demonstrates the possibilities, and then it's up to you how you want to do it, how symmetrical you want to do it, and the layout of the reinforcements. But this gives you much more freedom to apply reinforcement the way that you wish to do it, basically. All right, so let's continue with the crack width design. So let's take a look at the crack and the crack width top. And I can see here, for example, that I have some crack widths that are actually larger than my allowed of 0.2 millimeters. They are 0.24 or 25. And with the new setting under the auto design, there is a possibility to apply an iteration of the design to actually take into consideration these crack widths. So it would apply more reinforcement until the crack width is under the limit. So hopefully this will go pretty quickly. I'm experiencing a little bit slower calculation time since I'm sharing my screen and recording, but hopefully it won't take too much time. As you can see here, it's it's an iterative process, and it's you can set also the limitations of iterations and also the convergence criteria for the iteration. Yeah, okay, so it's finished, and here I can see that now the size of these cracks are under the limit. So it can be a very useful tool. Otherwise, it's a very iterative manual process. So now you can do it automatically for crack width design, also for slabs. All right, so let's continue with the shear reinforcement, and then we will go through the RC shell fire design as the last thing. So let's continue with the shear reinforcement design, which is a new feature also in FEM Design 22. So when I go back to the design selector, I can select surface reinforcement shear. And here I have some new options. So the first option is the shear control regions. And I have the option to define my own shear control regions or make changes to the already automatically defined shear control regions. So these are basically when you have a connection between yeah, so in this case, it's a wall connecting to a slab. So in this region, you probably will have some reduction due to the size of the wall and that the force is going straight down to the wall instead of shear, because it's modeled as shell, and shells don't have any analytical thickness, and that's the reason why you often want to apply some kind of reduction in these zones. So you can either ignore the shear check totally within a specific distance, or you can perform the shear check but do some kind of reduction of the forces, or not, if you wish. So let's still perform the shear check but have a little bit reduced force. The next setting is the calculation parameters, and you can find the quality for the shear reinforcement and also the cut theta value for the calculation. So let's apply an automatic reinforcement for the shear, which will actually, let's first start out and check without any shear reinforcement at all and see what the capacity is if it's no shear reinforcement, no shear links in the slab. I can take a look at the results, and I will find under the RC shell shear reinforcement the utilization. And I can see that I have some overutilization for the shear at the corners of this hole and also maybe at some other parts of the structure, but mainly here. And I can also see the utilization when it comes to the VRD max, VRDC, and S. So it's divided into these different settings. So also the design forces, and if we take a look at the reduction here, I can actually compare in the reduction zones that if you take a look here, it's a reduced value. So if I take a look at the normal shear force, it will be a little bit higher. So that is due to the reduction in those shear regions that I defined using this tool, if you remember. So the force used for the shear design is the reduced one found under VRD reduced here. So let's take a look at the utilization again and apply some automatic shear links in this area. I can also apply more reinforcement, longitudinal reinforcement, and take this into consideration this way, and that will actually increase the shear capacity of the section, but I can also add shear links. So let's go with the shear links for this. Auto design, and click on the red exclamation mark and right click on the slab. And this will generate the shear links in my slab. So let's see here. All right, so now we have some shear links applied here. I can take a look with manual design to see the properties of them. So I have 12 millimeters and a spacing of 300 here. And the spacing is actually corresponding to the base net. So if we take a look at the settings for the auto design for the shear links, I have spacing by bottom face, top face, or a user-defined value. But it's pretty common to have the same spacing for the base net as for the shear links So that's an option you can choose here. So in this case, I've applied some shear reinforcement, and I can take a look, as usual, the formulas. If I take a look at the utilization result, go to detail result and select, let's see here, a pen and a point of the slab. And I will get step-by-step calculations for that point. So here I can see the shear capacity of concrete compression strut according to this, and without shear reinforcement and with shear reinforcement. And you can see the different VRD max, VRDS here. So this view can of course be added to the documentation, and it's the same. I actually forgot to show that, but it's the same for the longitudinal check. So if we go back to the surface reinforcement longitudinal and do the same thing there, let's take a look at the utilization results and go with a question mark and choose a point. I can get step-by-step formulas for the check for the longitudinal reinforcement as well. And here you can see the different sectional forces and the forces in the reinforcement and concrete block, and also interaction surfaces, maximum, minimum reinforcement, and so on. All right, so that I only last thing to go through is the fire design. So let's do that now, and I will open up another model. And when you perform the fire design, you have to define a new load case called, you can call it whatever you want, but it has to be under the type fire here. And this is used as a marker to select which ULS accidental load combination should be used for the fire design. So in this case, I have created a new empty load case with plus fire, and I have created a new load combination with a type UA, as in ultimately mistake accidental, and I've placed this load case inside this load combination to indicate that this accidental load combination should be used for the fire design. Because you have other types of accidental load combinations, for example, seismic, or maybe some kind of impact load or something like that. So this is just to distinguish which load combinations should be used for the fire design. So let's go to the RC design tab and perform the auto design for the same bar, but in this case it's also including the fire design. But first, let's take a look at the settings. So you can find them, sorry, I need to select the bar reinforcement, go to the calculation parameters and select the bar. And here under the tab fire, I can select some settings for the fire design, basically. So you have some settings for the concrete, some concrete properties, reinforcement properties, and then you have the thermal settings. So you have the duration of the fire, which temperature curve you want to apply, and the time step. And also some settings specific to the fire design, which can be found in the Eurocode. So the easiest way is just to read here and you will find the different settings and what they mean. The fire design in FEM Design for concrete is actually based on a finite element analysis of the temperature gradient. So it's a thermal conductivity calculation to establish the temperature gradient in the cross-section. And you can actually set the mesh for this finite element calculation for the heat transfer here. So I can show the mesh and see the mesh in the cross-section. You can also apply different conditions to the different sides. You can have ventilated, exposed to fire, or insulated side. And this will of course influence the temperature gradient and how the temperature develops into the section. You also have two different design methods. You have one zone method and 100 and 500 isotherm. And the zone method, it's a little bit more nuanced. It's a more detailed method. It will actually reduce the concrete material properties with regard to the temperature inside the concrete, and it will divide the section into different zones to reduce the material parameters in these zones differently. However, there is a limitation for this design method, and it's that it can only be used for certain sections. So it's not for all different section types, basically. But for rectangular sections, it's you can use this method. The other method is a more general method, and it's basically if you exceed 500 degrees, the concrete will be assumed to be damaged and excluded from the calculation. And this method, the 500 isotherm, can be used for all types of sections. But let's go with the zone one. There are some other settings here if you want to take into consideration the change in the anchorage length, for example, because it's based on the material properties and you change the material properties for the fire design and so on. But let's go with this and do an auto design. And here you can see that there's another bar showing up. It's the heat transfer. And it's actually this finite element calculation of the temperature gradient that is carried out in this step. So let's see if it's soon finished. All right. So I will take a look at the detailed result for the RC bar. So I will display the utilization results and go to the magnifying glass and right click on the object. And this will show me a detailed result of this case. So by default, it is showing the maximum load combination that yields the maximum utilization. But in this case, I want to see the calculation for the fire design for the fire load combination. So I need to go up here and change it to the load combination related to the fire. So in this case, it will show me the calculation for this load combination. And here you can see the temperature gradient, the cross-section, and the damaged part of the concrete, and also the reduced material properties for the concrete using the zone method, and also the reduced steel material properties. And this is actually measuring the exact temperature in each position of each rebar and reducing each rebar's properties individually. Because it knows the temperature gradient of the whole cross-section, it can actually find the temperature in that specific point of the different rebar positions. So it's a quite detailed fire design, I would say. And then after this, it's the same check carried out with the exception of some additional checks here related to SLS, basically. All right, so that's the fire design for bars, and it works the same way for shells. The fire design for bars has been in the software for 2 years. The shell, it's new for FEM Design 22. So let's swap over to the surface reinforcement longitudinal and see the settings here. And it's basically the same settings for the bar. It works exactly the same way. The only difference is that this is like only 2 sides that can be exposed to the fire. Either the top or the bottom, or like the outside or inside. So let's carry out the auto design for this shell with regards to the fire design. And we can take a look at the calculation by going into the utilization and magnifying glass and selecting a point. And here you can see it's the same basic principle with the temperature gradient calculated by a finite element analysis and a reduction of the concrete and reinforcement in that specific section. And then it's the same check carried out, but with a reduced section and reduced material properties. All right, this concludes the webinar, and thank you so much for attending. If you're new to FEM Design and want to give it a try, please feel free to apply for a free trial on our webpage or use the QR code found here.